Yes, hi everyone. Let welcome you all and let's see the content from the topic chemical reactions and equations of the 10th class. Today I want to discuss with you that is rate of reaction, what is its meaning and which factors affecting upon rate of reaction. Rate of reaction, what we know, suppose we have the reactant A and that reactant is converting into the B. We are applying certain temperature, pressure, concentration, catalyst, certain reaction condition we are applying, and the reactant is get converted into the product. That's the chemical change or chemical reaction. Now the concentration of A, as the time proceeds, the amount of A is get decreased, correct? And initially the product was not there, but when we carry out the reaction slowly steadily, the concentration of product start to increase. Now rate, simply what it means, in a certain specific time span, say for example initial time t0 and after 5 minutes, initial time t0, at the 0 minutes or at the beginning of reaction concentration of A is 1 mole, and say for example after the 5 minutes concentration of the A, now it becomes 0 mole. Say for example the reaction is get completed, whole reactants are get consumed, concentration of reactants are get decreased. It means what, within a 5 minutes, okay, how much concentration is get decreased? 1 mole concentration is decreased. In how much time it get decreased? It get decreased in a 5 minutes, correct? So here 1 mole per 5 minutes, it means 0.2 mole per minute is the rate of reaction, correct? So a decrease in concentration of reactant. In the same way we can state in terms of the increase in concentration of the product. Say for example initially we were having 0 moles of the B, but after 5 minutes suppose we have the 1 mole of B. Now in terms of B, what we are seeing, how much increase in concentration? 0 to 1 means 1 mole concentration is get increased, and in which in how much time? In 5 minutes. So 1 mole upon 5 minutes, it also means 0.2 mole per minute. That much is the decrease in concentration of the B per unit per minute. Okay, so that is nothing but the rate of reaction. Rate of reaction is nothing but the change in concentration of reactant. Are you getting? Change in concentration of reactant, change in concentration of the reacting species. That is nothing but the per unit time, that is nothing but the rate of reaction. Briefly I will give, because lot of things we have to see. Otherwise, change in concentration, change in concentration of a reactant or product per unit time is called as a rate of a reaction. Okay, now let's see factors affecting upon a rate of reaction. Factors affecting on a rate of reaction. The first factor which affects upon a rate of reaction, that is nature of a reactant. How it affects? More the reactive the chemical species is, the rate of reaction will be more. Okay, for example here I'll write the reactivity series of metals: cesium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, hydrogen, okay, iron, tin, lead, hydrogen, mercury, copper, silver, gold. Okay, so in this reactivity series, metals which are at the top, they are more reactive, and those which are at the bottom, they are less reactive. So what will happen? Say for example if we choose here zinc, and another element if we choose here copper, which is more reactive? Zinc is more reactive, correct? So if we treat here zinc plus HCl, When we treat zinc granules with the hydrochloric acid, we will get zinc chloride. Hydrogen gas will be evolved. If we treat copper with the same hydrochloric acid, we will get here copper chloride and hydrogen gas will be released. Now the question is, tell me which is more reactive amongst the zinc and copper? Zinc is more reactive. So the rate of reaction will be more for this reaction. More the reactivity of the element or chemical species, more will be the rate of reaction. Simple one. Okay. Then after the rate of, here just for the 10th class students I am stating here, we can state the reactivity of non-metals, reactivity of other chemical species, but in brief, more the reactivity of the chemical species, more will be the, higher will be the rate of reaction. Second factor which affects the rate of reaction is size of reactant. Say for example, Shahabad tile we took, powdered Shahabad tile and pieces of Shahabad tile. Okay, you might know near to the Kalburgi, Gulbarga, there is a place Shahabad, and from that region we are getting specific type of stones from which the tiles, building material, constructional material is get made. So Shahabad tile, very oftenly you might have seen different layered white colored that tiles. So powdered Shahabad tile constituents, that is CaCO3, and the pieces of that Shahabad tile suppose we have, and suppose both of these we have mixed with the certain acid, concentrated acid. Let's have an example of hydrochloric acid. What will happen? In both the cases dissolution will take place and CaCl2 and carbon dioxide gas will be released. Here also the carbon dioxide will be released when we put powdered Shahabad tile in hydrochloric acid. Okay, in both the cases we have the same chemical equation, CaCO3 plus HCl will get CaCl2 plus H2O plus CO2 gas will be released in both the cases, but rate of reaction is more because here the particles are small in size. Smaller the size of particles, more surface area will be exposed, and as the more surface area will be exposed, the rate of reaction will be more. And here also, in another case opposite to this, the Shahabad tile, the pieces of Shahabad tiles, comparatively less surface area is get exposed. Okay, say so for example many particles are there, they are exposing more and more surface area. It is comparable with the for our digestive system. It is said we should chew 32 times, okay, whatever we are eating. Once each one we have to chew it for 32 times. Why? Because it should get fragmented in smaller and smaller parts and it is easy to digest. In the same way, smaller the size of reacting species, more will be the rate of reaction. Now next factor which affects, that is temperature. In general, what happens, greater the temperature, greater will be the rate of reaction. Okay, for many reactions, as the temperature increases, rate of reaction also increases. Say for example, what we do, say same example I am taking, CaCO3 instead of HCl. Now let's have a HBr. Okay, so we are getting here CaBr2 plus what, H2O plus CO2. So when carbonate react with the mineral acid, carbon dioxide is released. We know that. What is the confirmatory test for it? That carbon dioxide gas when pass through the lime water, CaOH twice, then there will be a formation of CaCO3 plus H2O. Okay, equation is correct, but let me make little change here. Suppose simple equation, if we took CaCO3 on thermal decomposition, CaO and CO2, calcium carbonate, limestone, on heating gives lime, that is calcium oxide and carbon dioxide. So how to know, how to confirm the gas produced is carbon dioxide or not? So for that purpose we should pass that gas through the lime water, and we are getting here the milky white colored calcium carbonate we are getting here. So it confirms the presence of the formation of the carbon dioxide gas. Now suppose this reaction is carried out at a low temperature. Okay, so low temperature means what? Carbon dioxide, less amount of carbon dioxide will be produced and milky white colored product will be lesser in amount. Okay, but suppose comparatively at higher temperature if we carry out reaction, the significantly noticeable milky white colored calcium carbonate will be produced. It means what? More the temperature, rate of reaction is more. Okay, then next factor which affects upon the rate of reaction, that is nothing but the catalyst. Catalyst is a substance which increases rate of reaction without being consumed. Say for example potassium chlorate, on heating produces twice of KCl plus thrice of O2. So in this case MnO2 act as a catalyst, correct? So these are the miraculous substances in chemistry. Many examples we can give. Sulfur dioxide when react with the oxygen result in the formation of sulfur trioxide. So we can use V2O5 as a catalyst, or we can use NO or NO2 as a catalyst. If we use V2O5 as a catalyst, solid, so reactant are gaseous, here it is solid catalyst, it is a heterogeneous catalysis example. SO2, O2 gaseous, and if we use NO or NO2 as a as a catalyst, so it is example of homogeneous catalysis. But these are the substances which increases the rate of reaction. Another example, N2 plus thrice of H2, it forms twice of NH3. So the rate of reaction is tremendously increased by ion in presence of K2O and Al2O3. So the substance which increases rate of reaction, so if there is a catalyst, rate of reaction will be more one, rate of reaction will be the higher one. Okay, so these are the some important factors which affects upon the rate of reaction. Okay, so today we will stop here. Okay, temperature, concentration also affects. Say for example, last factor, let me keep here, zinc. I am seeing here that today's time span is 13 minutes and 15 seconds, and within that I want to finish it. Okay, because something memory related issue. If we carry out zinc plus HCl reaction, zinc plus HCl, if there is a concentrated acid and dilute acid, if